Okay, this is the Walsall College GCSE Maths Educas Assessment 1, answers by Berty Trim. Okay, these sort of questions we need to do fairly quickly, as in order to get a grade 4, we've got to try and finish the whole test. So question 1, we could do column subtraction, but what I'm going to do is add 2 to 268 to get 270, then 30 to get 300, then 115. So the difference will be the sum of these, which comes to 147. Okay, next question. I think the best way of doing 6 times 10, and then 6 times 6, 36. Add the 2, 96. Okay, third question. A few students got this one wrong, so I would keep it as a fraction, do the numerator, which is 15, half 30. At this point, we've got a trick. So dividing by 6 is the same as dividing by 3, then dividing by 2. So 15 divided by 3 is 5, then half 5, so you get 2.5. Last question, caught a few people. So bid mass means the bits of underline we must do first. So 3 5s are 15, 4 divided by 2 is 2. And then we've got to add these two. So we should be getting 17 for that. Okay, not particularly my favourite question, these. So it tells us that 10 hours of sunshine in London. So here we've got 2.5 suns, so each sun has to be 4, with the half being 2, of course. So now we could easily write down what Newcastle is, 4, Liverpool, 4, 4 and 4, 3 4s. Birmingham, we might need to know that, it's 5. So anyway, first of all we've got to fill the key in. So each sun represents 4 hours. How many more hours of sunshine did Liverpool have than Newcastle? So you can see it's 12 hours in Liverpool, 4 hours in Newcastle, so that's 8 hours. 7 hours of sunshine in Southampton, complete the diagram. So we're going to need almost 2 suns, but a bit less. So I wouldn't stress over the diagram too much. That will get us the full marks there. Okay, so decimals, 7/10, 0.7. We should know from memory that 0.25 is a quarter and 0.03 is 3/100ths. The bottom one some people struggled with, so what we're going to do is we're going to make it into a fraction. So if we double the bottom, we double the top. So yeah, we doubled that to make it out of 100, so it's 0.22. Now revising, we've got to know all the basic fractions really, so you should know that a fifth is 0.2, so you can quickly do 3/5 0.6. You should know that 1/8 is 0.125. You should also know a third is 0.3 recurring. Okay, and then if you got, for example, for 20ths, we could work that out, because again, if we make it into 100 by times the denominator by 5, the numerator is 20, so that would be 0.2. Okay? Okay, Christmas turkey time. So the time is 20 minutes per kilogram plus 90. So we've got 8 kilograms. So it's 20 minutes per kilogram. So that's going to be 20 times 8, and then add the 90. Basically. So the easiest way to do this is to do 2 8s 16. Add a 0, so that's 160 minutes, add 90 minutes. I'd add 100 to 160, 260, knock off 10. So that'll be 250 mins. Okay, question 5. Fractions in the simplest form. So you could keep halving top and bottom. and get the answer a quarter that way. But if you know your times tables really well, you spot that 8 goes into 32 4 times and 8 goes into 8 once. 7/25 is a percentage, so again we want to get an equivalent fraction with the denominator 100. So we've got to times that bottom by 4, so we've got to times that top by 4, so it's 28 and 100, which is 28%. And the last one, 2/9 of 45, well, we divide 45 by 9 and times that by 2. So you know your times tables, 45 divided by 9 is 5, 5 times 2, we're getting 10. Okay, I've not actually checked the mark scheme for this one, but the fact it says draw and not construct means I think I can do it fairly quickly. So the first line is parallel to AB and goes through C, so it's something like that. You can see that line, like a train track, is parallel with that one. Second one, perpendicular, means at 90 degrees, so it's got to go through D and meet AB at 90 degrees. So I believe this will get you the 2 marks for this bit. Okay, part B, square base pyramid. So we'll do a quick sketch, quick isometric sketch, 3D, that's what you're looking at. Okay, bottom bit, Nicola, she thinks 190 degrees is obtuse. Well, an obtuse is an angle that's less than 180 and greater than 90 degrees. Okay, how many minutes from Brilfax to Drago, these fictional places? So with these sort of questions, you can't really use your calculator, so I think you best just add in chunks of time. So how long from 8:25 to 9:08? So I would add 35 minutes to 8:25, takes me to 9 o'clock. Then add another minutes. So if we now add these 2 bits together, it's going to be 43 minutes journey. Okay, part B. So I would tend to read these twice actually to really understand what's going on. So basically what's going on is she's doing a commute from Ashby to Elderville. I've heard of Ashby to Lazeus, I've never heard of Elderville. So normally, if all going well, leaving then, getting in then. So we now work out that time. So I'd add a minute, that gets me to 8:20. Then add 40 minutes, that gets me to 9 o'clock. And then add 17. So again, if you add these 3 bits together, that's 58 minutes. Okay, but she commutes every day, 5-day working week. So the total time is going to be 5 times 5 is 25, so that's 250. 5 times 8 is 40, so that's 290 minutes. So that's the ideal. But there's delays, isn't there, in real life, and it's taken 5 hours 60. So in terms of minutes then, we're doing 5 times 60, add 6. So 5 6 is 30, add a 0 is 300, add 6 to 300, 306. So we've got here, that's the ideal time, this is the actual time in reality, and the difference of these is going to be the lateness, isn't it? Which is 16 minutes. Okay, this sort of question, there's a few ways of doing it. I'll offer you one way of doing it. If you ask for help in lesson, I'll come round and see how you did it. Okay, assume you got it right, of course. So you've got 3 bottles of milk. So also you've got to show your workings with this one. So you've got 3 bottles of milk, 150. So you're definitely buying them. That's 450. You've got a loaf of bread, is £1.40. So as we've got to show workings, I may as well do column addition. So at the moment it's costing £5.90 for the milk and bread. So if I now got my change out of £10 note, and I wouldn't do column subtraction, I'd do addition again. So add 10p gets me to £6, so that's going to be £4.06. Sorry, £4.10. Change from £10. But you are actually getting 60p change, not including the butter. So with the butter, which means I've got to take 60p off this. So taking 60p off this is £3.50. Yeah, so that's the change I actually get, which means I've accounted £3.50 now for the butter. So now I've got a half £3.50. So again, I'll do this by chunking. I do half of £3 is £1.50. Half of 50p, 25p. So we're getting £1.75. Okay. Okay, another functional question here: working time, money, etc. So 22-hour working week, £14 an hour. So we've got to do this. People do multiplication in lots of different ways. There is box method, Chinese method, all sorts. I'm going to do it the old traditional method. So 2 times 4 is 8. 2 times 4 is 8. 0. Come in tens. 1 times 2, 2. 1 times 2, 2. Add. So that's £308. But you get 1.5 times your money. This used to be called time and a half after those hours. So you're increasing £14 by 50% basically. Or you could think of 14 times 1.5, same thing. That comes to £21. So that's your new hourly rate. But altogether, Adrian's working 28 hours, which means 6 more hours labour. So we've got 6 hours at £21 an hour. 6 times 2 is 12. Add a 0, that's 120. Add the 6. So £126 overtime. Okay. So all the money then they're going to get is your 308 and your 126. Which is £434. Okay, part B is the paying actually increased by 10%. So what I would do now is recycle that, because that's what they get paid for the 22 hours. And I would increase that by 10%. So what is 10%? Divide by 10. So 10% of 308 is £30.80. And then I'm going to add that onto that. Okay? So if it was 10% increase, I should get £338.80, but I'm only getting that. So it must be less. I'm assuming again, I've not got the mark scheme, you've got to do a conclusion mark to get the 3 marks. Once you get algebra, you can do these super fast, okay? So all I'm going to do is add 3 to 27. So 6x is 30. And again, times tables, 30 divided by 6 is 5. So that's my value of x. Now, we could put that back in to check it. 6 times 5 is 30. 30 take away 3, 27. Check. Second one, do the numbers. 2 times 2 times 3. So 2 2s are 4. 4 times 3, 12. Most of you actually got the algebra right. W times W times W, W cubed. Done. C part 1. So I think with these, like, think of a random number. So Nick spent, let's say, 10 minutes on his mobile phone. Ellie spent 10 minutes less. Okay? So what would Ellie be? Obviously 0. If Nick spent 20 minutes on his phone, Ellie would be 10 minutes. If Nick spent 1,000 minutes on his phone, Ellie would be 990. So whatever Nick does, you're taking away 10. So K minus 10. It's that straightforward. Part 2. Again, similar thing. Pick a number, £5. So writing expressions change £5 into pence, you just do 5 times 100, don't you? So whatever the cost is in pounds, T pounds, you times by 100. But we write that like that. You still probably get a mark for that as well. Okay, Ollie's average speed between 1 o'clock and 3 o'clock. So they've travelled 20 miles in 2 hours basically. So there's a couple of ways to explain this. One would be, you remember this, the distance, speed, time triangle. So it's doing distance divided by time, speed. So it's doing 20 divided by 2 is 10. Okay? That's one way of doing it. The other way of looking at it is to do the gradient of this graph, basically, which is the change in the y, which is 20, divided by a change in the x, which is 2. You get the same answer as 10. Okay, flipping over. Give an explanation for the shape of the graph between 5 o'clock and 6 o'clock. So 5 o'clock and 6 o'clock, what's happening? It's flat, so therefore you're not moving, because an hour about has passed and you're still 40 kilometres away. So like that, we're actually moving in a circle. But yeah, stationary is what it's looking for. Well, at rest. Between which two times was Ollie cycling the fastest? So that's where you cover the most distance in the least time, which is this bit here. In other words, the steepest gradient. You can see that's between 3:30 and 4 o'clock. So you can put 15, 30, and 1600. Yeah, or use 12-hour system. So Ollie started the final part of his ride at 6 o'clock. He cycled 20 miles, an average speed of 8. Complete the graph basically, yeah? So we need to work out the time. So using the cover-up method, the time is the distance divided by the speed. So the distance is 20. We're dividing by the speed. Now, again, this is non-calculator paper. Dividing by 8, the best way is to half, half, and half. So half of 20 is 10, half of 10 is 5, half of 5, 2.5 hours. Okay, so you're starting at 6 o'clock. And you're going 20 miles in 2.5 hours. If you start in here, you're going 20 miles. So you're going to go from mile 40 up to mile 60 in 2 hours. So 6 o'clock, 7 o'clock, 8 o'clock. So get a straight edge. Done. Okay, so no, the square root of 400 is 20, because 20 times 20 is 400. Calculate this one. So 5 cubed, it's not 15, it's 5 times 5 times 5, which is 125, plus 5 squared, which is 25, which gives you 150. Write down a number that's both a factor of 16 and a prime number. So it's a number that goes into 16. So things like 4, things like 2, things like 1, 16. So there are a few I wrote down, in fact that's probably all of them. Which one's a prime number? It's 2. Given this, what's this? Okay, so that times that is that. So that divided by that is that. So let me write that down. 10,296 divided by 132 is 78. Okay. So we want to know what that is. Now actually I'm going to write this a different way actually, make a little bit of a mistake there. So rewriting that, 10,296 divided by 78 is 132. So if we look at a pattern, you can see that the answer is going to be, because you're dividing by an extra 10 basically, that's going to be, the answer will be 10 times smaller. So we don't really need a calculator or do any long division or anything like that. So hopefully you get that. So that basically that's 10 times bigger, so that answer's going to be 10 times smaller. So 13.2. That's what you want, yeah? These are 3 marks, ladies and gentlemen, yeah? And these are 3 marks. So the school's massive, it's like 1,500 people, and you're asking 10. So you need a bigger sample. You need to ask more people. Okay, you talk about school uniform, and you know the best dressed kids. When I was a school teacher and at school myself, were year 7. Okay, so you need to ask different age groups. So it's like the odd question where you can waffle and get marks in maths papers. Okay, here we go, Harry Kane. So we can either work in percentages or fractions. I'm going to choose to work in percentages. So 3/10 tackling, 3/20. We're going to change into percentage. So we've got times top and bottom by 5. So 15% of the time tackling, 18% of the time shooting. So we're going to add these two together. So 33% of the time is shooting or tackling. So all I've got to do now is subtract that from 100. So again, I'm going to do it by adding. So I'm going to add 7%, that gets me to 40, and then 60 gets me to 100. It's pretty much 2/3 of the time passing. He's probably a midfielder, isn't he? B. Harry borrows £80 to pay for a new pair of boots. Simple interest, which never happens in real life, is 5% per month on the month he borrowed. Harry does not make any repayments. After how many months will he owe £120? So 10% of 80 is £8. So therefore 5% is £4. So he does not make any repayments. How long does he owe £120? Okay, so basically how long does it take to build up an extra £40? So it's per month. So we're doing £40 divided by £4 per month simple interest, so that'll be 10 months. The debt will grow by an extra £40. I think I've read that question right. Okay, bearings. You're going to need these bits of equipment: protractor, ruler, sharp pencil. It's got to be with a certain accuracy for these questions. So points Y and Z are shown on the scale drawing below. Point X is 200 metres from point Y on a bearing of 150. Point X is on the same scale drawing. Give the bearing X from point Z. Okay, so we've got to first of all draw point X. So we're on a bearing of 150. So I've been doing this for my classes. So I'll be disappointed in my classes if you get this one wrong. We've done it quite a bit. So remember I told you, extend your north. North is 0, 0, 0 degrees, and we measure the clockwise rotation from north to the direction we need. So that's 0. So we're using this outer scale because that's clockwise to the direction we want is here. So X is going to be on this point somewhere. So I'm going to draw a construction line now, that's a faint line. But it's basically 1 centimetre is 25 metres. So we're doing 200 divided by 25. Well, there's 4 25s and 100, so it's got to be 8 centimetres. So 8 centimetres is also 80 mil. So there, X marks the spot. So that's point X. So we need to the bearing of x from z. So better off you're thinking now, bearing of there to there, but actually going from z, we're going that way. So again, extend your north, and we can measure this obtuse angle here, and that's our answer. So put my protractor in right place. I'm going to extend this line to get a more accurate reading. So looking to me, room is a bit dark, that's about 105. It's already 3 figures, so that's my answer, 105. Good old ratio. So, there's some marbles in the bag, between 30 and 40. Amy and Berty share in the ratio of 1 to 8. So every 1 for Amy, there's 8 for Beatrice. So we basically, there's 9 has got to go into a number. So the only number I can think of that 9 goes exactly into between 30 and 40 is 36. Okay, so 4 9's 36. Which means Amy has got 4 marbles, Beatrice, whatever her name is, 32. So what does it want? Yeah, it's Amy, 4 marbles. I found this question confusing, to be honest. So I'll explain it the best way I think. So we've got C and D, 3 to 5. You see at the moment the difference is 2 marbles. So let's just times both by 10. And here you can see Davina has 20 more marbles. Let's times both by 20. Sorry, that by 20. So it's going to be 60 for Chloe. And 100. You can see there the difference is 40. So we're not going to times by 10. So here, sorry, the difference is 20. There, the difference is 40. We want a difference of 30. So you might think, okay, rather than times by 10 or 20, let's choose something in the middle. Let's times by 15. So we do that, we get 45. We get 75. So that is 30 more. Okay, we could do it algebraically, but that's how we've done it. So 45 and 75. Again, this sort of functional level 2 question can be done in different ways. So I'll show you one way. So it says here exactly in bold, so that's obviously going to be really important. The right amount of flour, 30 large bags. So how much flour is this? So we need 30 of these bigger bags. So we're going to do 30 times 2.5. So the best way of doing this is double 30, 60. Half of 30 is 15. We're going to be 75 bags. Sorry, kilograms. The flour. Okay, so that's what we need. So the question is now, how many of these small bags are we going to need? So we're doing 75 divided by 1.5, which on a non-calculated paper looks horrendous, but let's write it as a fraction. And then let's times bottom and top by 10. So 750 divided by 15. So 15, 30, 45, 60, 75. So that's 5, so 5, 15, 75. So there's going to be 50 bags. So 30 bags are big, 50 bags are small flour. Now it's just the money, isn't it? So we're going to do 30 lots of £1.10. So again, I try to do this mentally to save time. I do 30 times 1 is 30 quid. 10p times 30 is 300p, which is £3. So my big flowers, £33. 50 bags of 80p. Again, that looks horrendous, but let's do 50 times 80, work it out, our answer out in pence, then convert to pound. So 5 times 8 is 40, 2 noughts, pence that is though. So 4,000 pence is £40. So we can see the difference is £7. This is another topic my class spent quite a bit of time on. So you must give reasons for each step. So annotate over the diagram so you can see this is an isosceles triangle. So if this is 50 here, these two angles must be the same. Okay, so 180 minus 50, and then we're halving that to get those angles basically, yeah? So half 130 is going to be 65 degrees. So write that in there. So we've now got angles round a point, which add up to 360. So all we've got to do is take away 40 plus 65. So mentally what I do here is say that's 100. So 360 add 100, take away 100 is 260. But then you've got to take off another 5. So it's 260 minus 5 is 255, which proves that. I think this would be enough explanation to show to get full marks. Bit more of an abstract probability one in my opinion. So it's about ratio, okay? So basics probability then, got up to 100%, aren't they? But it tells us that a yellow counter is twice the probability of an orange counter. So first of all though, I'm going to write the colours out. So we've got some red, some yellow, some orange, some green counters. So a yellow counter is twice the probability of orange. So if we put a unit for orange, a yellow must be 2, so that's twice. So we've done that sentence. Second sentence, a green counter is 3 times that of yellow. So the green must be 6 units. Okay, so we can't simplify that ratio anymore because of the 1. So part B, the probability of selecting a red counter is 0.46. What is the probability of selecting a green counter? You must show your working. So I'm going to convert that into a percentage. So that's 46%, which means these 3, so 4 gets me to 50%. So those 3 are 54. Okay, so I've got to make 9 units up to 54, so I'm timing them by 6. So it wants to know the probability of green, so the same colours, they're in the same order still, so yellow, orange, green. So all I've got to do is 6 times 6, which is 36%. Now if I got that wrong, it's because Michael was knocking on the window behind me, putting me off. Just go show why I'm recording this video. I'm a lot happier to do these off the cuff than the number ones, because I think if you rehearse and practice, it's hard to get these ones wrong. Expand and simplify. So you've got 3 times 5a is 15a. We've got 3 times minus 2 is minus 6. We've got minus 2 times a is minus 7a. And we've got minus 7 times minus 4 is plus 28. So expanded, now I simplify. So you've got to collect those numbers together. So those numbers add up to 22. bring my algebra together. So that's 8a. But don't forget the plus side in the middle. So part B. Show that the triangle is not isosceles. You must use algebraic method and not trial and error. Okay, so not isosceles. So what we could do is find out the value. This is 5 marks, so it's going to be a grade 5. Plus it's question 20. So we know that the angles in a triangle add to 180. So in the first part we're collecting terms, so we're going to do the same here. We're doing 5 plus 6 plus 8. So that's 14 plus, so we've got 19x. Add the numbers. So 7 minus 27 is minus 20. Minus 9 is minus 29. That equals 180. So this looks unsolvable, but it will be solved. So add 29 to 180 is 209. So now I've got a horrible division, 209 divided by 19. So how I'm going to do this, I think the best way is probably guess. So if that was 20, then there's 5 20s and 100, so let's try 10. So we do 10 times 19, 10 times 19 is 190, so I can squeeze one more on at 11. So let's check. So that's going to be 190 plus 19, you see that's right, 209. So I found x basically. X is 11. So now that I've got x is 11, I can work out each of the angles and prove it's not isosceles. So here I've got 6x minus 9, so that's 66 minus 9. So take away 10, add 1, so that's 56, 57 degrees. So this corner is 57 degrees. Okay, this one, 5x plus 7, so that's 55 plus 7, which comes to 62. So that angle is 62. So I could do this 2 ways really. I'm going to do it by adding these 2 and subtracting from 180. So those 2 are 110 plus 9, so them 2 are 119. Which means this angle, 1 gets me to 20, 61 degrees. So it's not far off being an equilateral triangle, but it's not isosceles. So maybe I have to write a statement here, like all the angles are different, it's scalene. I reckon the word scalene has all angles different. Okay, this is a bit of a weird one. So vectors, so P plus Q, we'll do that first. So you add the tops and the bottoms. So that's P plus Q. So we've got a number times that vector, so this number times by each of these numbers, and you get in 5 over n. So the key really is the 2, isn't it? What do you times 2 by to get 5? And that's 2.5. Okay, so n must be 2.5. So if I now times 6 by 2.5, that gives me n. So double 6, 12, half of 6 is 3, 15. Okay, mean from the table, it's always the same. So mid-interval value, 5, 15, 25, 35. So that all mid-interval value is, we don't know if the times 0 or 10, or less than 10, sorry, greater than 0, so we pick the middle. So all we've got to now do is multiply. So if 10 deliveries are 5 minutes, that's 50 minutes, and then do the rest. Estimate for the mean time, 50 deliveries. Okay, so 12 times 15, so I've got, I'm going to partition it, so I've got 10 times 10, that's 100, and then I've got 10 times 50, and I've got, I'm not sure if I actually want an estimate or to work out exactly, so let me just start again on this one. So you've got 50 there, I'm going to do column multiplication here. So let's do that one. 2 5s are 10, 1 2 is 2 add 1 is 3, put a 0, 1 5 is 5, 1 1 is 1. So that's 180. I think half this one is do 100 times 16 is 1600, then half that twice, so 1600 becomes 800 becomes 400. 35 times 12. I'm not sure who wants you to do all this, but I'll do it anyway. 2 3s are 6, and 1 is 7. 1 5 is 5, 1 3 is 3. 420. So we've got to add these now, these four up. So what we got? We've got 820, that's those two, plus 185. So that's 10,005 minutes, 50 deliveries. So it tells you there. So we've got to divide that by 50. So the trick for this is divide by 100 then double. So dividing by 100 is 10.005, double 20.10. I ain't sure if you have to be that exact for that question. Next part then, so calculate an estimate of the percentage of deliveries that took 25 minutes or more. So this class interval is between 20 and 30. So we could assume that half of them were more than 25. So let's call it 12. But then obviously all of these are above 25 minutes. So it's 12 add 35 is 47. But I did the wrong half, so I was looking at interval there, sorry, so I've got to half that 8 and all those 12, so it's actually 20. So we're thinking 20 deliveries were over 25 minutes out of a total of 50 deliveries. So if we double top and bottom, that's 40% of deliveries over 25 minutes. It can either be an estimate, okay? Okay, first when I saw this question, I jumped into it and got it wrong basically, because I've just noticed different units. Okay, so we've got to convert one into the other. It's not times by 1,000 or 100. So what we need to know is we need to know that 10 millimeters is equal to 1 centimetre. So if we had a square measuring 10 by 10 mil, that's 100 millimetres squared. We have an identical square that's 1 by 1, that's 1 centimetre squared. So actually we've deduced that 1 centimetre squared is 100. So what I'm going to do is I'm going to convert 300 into centimetres squared. So I've got to divide that by 100. So we've got 15 to 3, which simplifies 5 dot dot 1 by dividing both by 3. So that's your final answer. It's 23, so I should have been wiser there. But yeah, your main learning bit here is this square, that 1 centimetre squared is identical to 100 millimetres squared. So for every 100 we got a centimetre, so that's 3 centimetres. Okay, cake. So again, I like to write these out because they're always consecutive. So you've got flour, sugar and dried fruit, DF. Okay, what fraction of the main ingredient is dried fruit? So that's 7 shares out of a total of adding those up, which is 15. So that's straightforward. And again, I'm going to write the ingredients out consecutively. It says that the combined mass of flour and sugar, so then them two combined, is 560. So them two combined is 8 shares. So if you know 8 times tables, we're timesing by 7, aren't we? Or if we're going this way, dividing by 70. Okay, so I want to know the mass of the dried fruit. So I've got to times 7 by 70. 7 sevens are 49, add a 0 grams. Again, so having quickly read this question, it's slightly different to ones I've seen in the past. So here we've got to know the AND rule. So basically the AND rule, you multiply probabilities, okay? So Hannah wins a badminton match, probability of winning a badminton match is 9 in 10 chance. So they're playing against each other. So therefore it's mutually inclusive. So if it's 9/10 for Hannah, it's got to be a 1 in 10. Okay, so that's that first bit of the table done. Next bit's a bit more tricky though. So it's saying here the probability that Hannah wins both badminton and tennis is 9/50ths. So whatever this is here, when we times them, we're getting 9/50ths. So the only way to get that would be this fraction here. Because when we times fractions, you times the top numbers. 9 times 1 is 9. So what we times 10 by to get 50, and that's 5. So it's a 1 in 5 chance, basically, of Hannah winning a tennis match, which means mutually exclusive 4/5. And then as their tennis ability is the same, basically these stay the same. So we've done that 4 marks. Wasn't too bad actually. Oh no, we've got to complete it. So we've also got to do all these. So we've got to do 9/10 times 4/5. So 4 9s are 36. There we 50. There we got 1 times 1 is 1. 5 times 10 is 50. And at the bottom we've got 1 times 4 is 4. 10 times 5 is 50. So the key thing is these should add to 100%. 4 and 36 is 40. Sorry, should add to 50, beg your pardon. Yeah, they do. So that's all good. So part B, calculate probability that Hannah wins exactly 1 match. So wins 1 match is, I'm going to shade this in. So she wins and then Imran wins, or Imran wins, then Hannah wins, and that's the only way she can win 1 match. So it's 9 in 10 and 4 in 5, or, as we put for or plus, 1 in 10 and 1 in 5. So evaluate these probabilities. 4 9s are 36, we've got 36 in 50, add 1 in 50, which is a 37 in 50 chance. If you double that, 74% chance basically. Yeah. So yeah, at the beginning then I should have said also using the or rule. So the or rule is you add when you have or in the sentence. Okay, so here you've got a congruent means identical. So triangle A is congruent to triangle B. So you can see, I've worked out other angles. So yeah, this could be flipped of that, couldn't it? Because that bottom's 60. So they are similar, but not congruent because it's saying that's 10. This could be bigger or smaller, so we need more information. Triangle C is congruent to triangle D. So we've got 10 here, 10. Being disturbed again, 60, sorry, 105, yeah, so that's 105, 75, yes, that's right, 75. So yeah, I'm thinking now, if I cut this out and then flip it, then yes, so you've got to visualise that. So imagine cut that and then flipping it around this way, then it's the same as that, because that 10 goes there, that 75 goes there, that 60 goes there, and so on, yeah? So I did that wrong there, that's 75. Right, so yes, that's they are the same, they're congruent, so that's true. Triangle A is congruent to triangle C. So the 10 centimetres is between these angles, isn't it? So let me just get this angle again. So 75 and 60, 120 plus 15, 135, away from 180, so that's 45. Yeah, so these could be congruent actually. I may have made a mistake in the last one. So let's do this one, then I'm going to correct the middle one if I'm wrong. So, so the 10 is in between 75 and 45. Yeah, so that's false. And yeah, that's probably right, because you got a 1 of each, haven't you? Okay. You probably have to check the mark scheme on this one, because I'm not too sure exactly what it means. So, is it possible to draw an isosceles triangle with an exterior angle of 60? So, does it mean, so these two are the same, the exterior, that being 360, so that being 60, which means that is now 300, and that's obviously impossible, because angles in a triangle add up to 180. It could mean this actually, is what I first thought it meant. So if that external angle, and it's not to scale, is 60, then this angle here must be 120, which then these two are going to be 180 minus 120 is 60, split each time of 30, which means yes, it is possible. So I think it's that one. I'm not 100% sure, so I might be dropping 2 marks into that. Part C, show that these two are similar. So similar means basically one's a shrunk version of the other. So if they're similar, then ratios are the same basically. So you got, so what's your longest side, isn't it? So we've got longest side here is 12, the longest side here is 9. So what's that ratio? So we've split that ratio down, divide bottom and top by 3, we've got 4 over 3. Now if I test this on this side, if it's similar, we should get that. So I'm doing 8 times 4 thirds. So 4 eighths, 32, and you're getting a decimal, aren't you? So it's not that. Let's test it on the 6. 6 times 4 thirds is 24 divided by 3, which is 8. So they're not similar. But it's saying they are. Okay, so longest side ratio comes down to 4 over 3. And now I'm going to do the shortest sides. The shortest sides on this one is 8. The shortest side on this one is 6. So we're going to do 8 divided by 6, which you can see is 4 thirds. And finally the medium one, so that's a shorter one. That's the one in the middle. Medium, sorry, not medium. So the medium one, you've got 10 and 7.5. So divide bottom and top by 2.5. You got that same ratio again, so that proves that they're similar.